The world is witnessing a paradigm shift in warfare and security threats. Drones and autonomous weapons are no longer futuristic concepts confined to science fiction. They are rapidly becoming a reality on battlefields and in civilian airspace, presenting both unprecedented challenges and opportunities for national security. This essay will delve into the pressing need for advanced counter-drone and robotics defense systems, highlighting the implications of these technologies for the future of warfare. The proliferation of inexpensive, commercially available drones has empowered both state and non-state actors with sophisticated surveillance and strike capabilities once reserved for powerful militaries. This has created a significant vulnerability, particularly for critical infrastructure, public events, and national borders. The threat extends beyond individual drones to encompass coordinated drone swarms, capable of overwhelming traditional air defense systems. Russia's aggressive use of military robotics, as seen in the ongoing conflict in Ukraine, underscores the urgency of this issue. Russian forces have deployed unmanned ground vehicles and loitering munitions for reconnaissance, targeting, and direct attacks, demonstrating the evolving nature of modern warfare. This highlights the need for nations to develop robust countermeasures to neutralize these threats effectively. As autonomous systems become increasingly sophisticated, the potential for accidental escalation and unintended consequences rises. Therefore, it is crucial to develop counter-drone and robotics defense systems that are not only effective, but also adhere to international humanitarian law and ethical considerations. This necessitates a focus on non-lethal technologies that can disable or neutralize hostile drones and robots without causing unnecessary damage or loss of life. Addressing the complex challenges posed by drones and autonomous weapons requires a multi-layered approach that combines traditional air defense systems with innovative, non-lethal technologies. These technologies aim to disable or neutralize hostile drones and robots with precision and minimal collateral damage, making them ideal for civilian environments and scenarios where lethal force is not warranted. Static electric shock systems offer a promising avenue for countering small drones. These systems utilize directed energy beams to disrupt the electronics of a target drone, causing it to crash or land safely. EMP systems operate on a similar principle, generating a powerful electromagnetic pulse that disrupts electronic circuits within a specific radius. AI-driven countermeasures are another crucial area of development. AI algorithms can analyze sensor data, identify potential threats, and autonomously deploy countermeasures with minimal human intervention. This enables rapid response times and reduces the cognitive load on human operators. Sonic disruption systems exploit the sensitivity of drones to high-frequency sound waves, disrupting their sensors and communication systems. Finally, physical neutralization tools, such as nets, high-powered lasers, and interceptor drones, provide a direct means of disabling or capturing hostile drones. These systems can be deployed independently or in conjunction with other countermeasures to provide a comprehensive defense strategy. While drones pose a significant threat, the challenge extends beyond unmanned aerial vehicles to encompass a broader spectrum of hostile robotics. This includes unmanned ground vehicles, autonomous underwater vehicles, and increasingly sophisticated autonomous weapons systems. Addressing this challenge requires innovative solutions that go beyond traditional counter-drone technologies. One promising avenue of research is the use of beta ray radio transmission for reprogramming hostile robotics. This technology leverages the penetrating power of beta rays to deliver software payloads to electronic systems, potentially allowing for the reprogramming or disabling of enemy robots in the field. While still in its early stages, beta ray radio transmission holds significant potential for future defense applications. The ability to neutralize or even repurpose enemy robotics could provide a decisive advantage in future conflicts. However, this technology also raises ethical and security concerns. The potential for misuse or unintended consequences underscores the importance of responsible development and international cooperation to establish clear norms and regulations. The development of robust counter-robotics capabilities is essential for maintaining national security in an era of rapidly evolving technological advancements. By investing in research and development, fostering international collaboration, and prioritizing ethical considerations, the United States can ensure its continued leadership in this critical domain. As the global leader in military technology, the United States has a responsibility to champion the ethical development and deployment of counter-drone and robotics defense systems. This includes prioritizing non-lethal technologies, minimizing collateral damage, and ensuring compliance with international humanitarian law. By setting a high bar for ethical conduct, the U.S. can encourage other nations to follow suit and foster a more responsible global security environment. Continued investment in research and development is crucial for maintaining the technological edge in this rapidly evolving field. The U.S. must prioritize the development of innovative countermeasures, such as beta ray radio transmission, while also exploring the potential of emerging technologies like artificial intelligence and directed energy weapons. International collaboration is equally vital. Sharing information and best practices with allies and partners can enhance collective security and promote the responsible use of these technologies. This includes working together to establish international norms and regulations governing the development, testing, and deployment of counter-drone and robotics defense systems. The rise of drones and autonomous weapons presents both challenges and opportunities for national security. By embracing innovation, prioritizing ethical considerations, and fostering international collaboration, the United States can effectively counter these emerging threats while upholding its commitment to global security and stability.